This particular picture is of our geodesic dome greenhouse. You can see that one of my classes just finished building this ramp. We have a couple of students who are in wheelchairs, so we have them to have access to our greenhouse. Inside this greenhouse is a large tank which we have water in that we actually heat with solar energy to bring the water up to help us keep the temperature at a more survivable temperature in the middle of the winter. We're at great hopes in the future here of adding a solar collector to preheat the water and help the water stay a little warmer so we can grow more tropical fruits and vegetables in the wintertime. Right now that doesn't really work too well. I'm going to skip ahead here a little bit to our next video. This is of our wind turbine. Wind turbine was put together, put up last year in support of the pre-engineering class. We have competed the last 3 years in the Wind Blade Challenge up at University of Maine at Orono, and we actually build these types of blades. We don't actually build the power generating capacity, but we generate the blades themselves and fuse them as part of a composite industry project. Right here I'm going to have a student do a little demo for you. We'll talk a little bit about
why don't you explain it to the group if you can?
some data that we're getting.
Guys, listen up! Well, got a few things it shows. It shows your RPMs, which is the rate it's spinning. It's not too fast right now. We're generating 0 watts right now of power because it's using some to spin the blade right now. As you can see, it's moving. That's the last month. I mean, even though it says 12, at one point it might have been generating 12, but that was not the average for the whole day. We need all the evidence we can get.
Let's stop the video here. That was Ben. Ben's worked with me all semester. He's in an alternative energy class with our GT coordinator, and Ben is also has helped quite a bit with collecting data, collecting information. At this point in time, the wind turbine has not generated really any amount of power, partly because when it was fully installed, it was in the summer, and we know by the placement of the wind turbine next to the school and with the wind off the river coming at it, that most of our power is going to be generated in the winter and not in the summer. And I've had to explain to the students that this wouldn't be the ideal location for a wind turbine. It's not a horrible location, but it's not an ideal location. And the other thing is, with these small wind turbines, they're not really big enough to generate a huge amount of power, and we probably wouldn't want a gigantic wind turbine next to a school because of some of the noise concerns and stuff. This one doesn't make an awful lot of noise. The next part of this video is showing you just a quick overview of what my robotics students have been doing. They're in the process of competing, going to a competition, and they're actually building their robots in this video here.
Just comes back to smack me in the face.
Doing some testing on the component. We have 5 teams at this point competing, building their robots, and then on the day that you see this, we'll be at our competition at Gorham. This is one of my veteran students here. He was one of the students who went to the World Championship last year. Pretty complex robot. Let's see if we can skip ahead here a little bit, get a couple of his teams. The challenge this year is they have to reach up and put a ball in a goal that is very, very high. It's something like 20 inches off the ground. I'll stop the video here. This is another thing that we were able to do every year as part of something I do with my program. We take all freshmen to the Augusta Civic Center to what's called the Craft Championship. What the Craft Championship is a program where they expose kids to a lot of trades, and what was kind of neat is most of the kids in my classes also went to this field trip, because I do have quite a few freshmen, and in the kids who didn't go this year had gone the year before when they were freshmen. What's kind of neat here is you got Chimbro in a bucket truck, and you'll see throughout the video there are other electronic things going on. Each student was able to go up in this truck, and they go pretty high, as high as 55 feet in the air. Oh, I've got another video from the other class. This is back at the Craft Championship. A couple students building some hydraulic lines, learning how to do that. Trying to really give the kids an overview. Back outside to the boom truck. The kids also got the chance to climb on a pole if they wanted to do that. They could actually go up there, which is kind of cool. Give them an experience of what it's like to be a line worker. It's kind of a cold day, but inside they could see students competing in electrical wiring competitions. Students didn't actually do this, but they could see the other students competing in it. And then there is a table in one of the sections where the kids could actually do some electrical wiring, which is kind of neat. We also did this a little bit in one of my classes to start talking about power. You see that the Civic Center is pretty busy, pretty active. There's some electrical boxes here for the kids to see. This is now back to what we're going to be doing this spring, and this is the Wind Blade Challenge. Students design a foam blade, wrap fiberglass around it, and cut it, shape it, form it. They do a lot of design, engineering work. And then at this point we have a couple engineers in here working with the kids. They cut out the fabric, and then we usually have about 30 kids doing this in one day. And then this is the infusion process where they take fiberglass resin and insert it, and it's almost like a vacuum bag, freezer bag, but it pulls that together. And then right now we're going into the actual final competition. A little glitch here in the video. This is the Wind Blade Challenge. This is up at Arena. This is the winning team, state championships last year. This is their wind turbine spinning. You can see that they generate electricity. They also put a load on this, which is kind of interesting. Then a big part of this also is the oral presentation. This particular one here, this is the group that won the whole thing last year. They do an oral presentation. Sorry about the camera work. And they do the science behind how they designed their wind turbines. Technical design, the engineering, you see some of the pictures in the background. This is of another group who's competing in the Windstorm Challenge, which we also do. We bring 3 wind blade teams and 2 windstorm teams. This year we're looking doing 4 and 3, which is another one. The Windstorm Challenge, the kids actually do a floating platform and get in the water, which is kind of interesting. And they have to design a platform that can withstand waves, wind, and power. To look at some of the different alternative energy sources that are out there. Let's see where this goes. This is another presentation by another group, and this is how the award ceremony. And that kind of concludes my overview. And you'll see we have a fairly active program, a lot of things going on, and hopefully this concludes, gives you an overview of what I've done this year and what I hope to do this year. Thank you.